Okay, students, welcome to today's most important class in this course is about life cycle assessment. And based on this, you have a CA1, right? So make sure you pay attention. Today, the speaker is actually my own former team member. He's now in UK. He set up a company based on this idea, and he sold the company to a big company, and he's happy. He's also set up another artificial intelligence based life cycle assessment and ESG reporting, environmental social governance reporting. So he's actually the guy literally doing the practice. And he will walk you through his slides, and then I will record them. So that would be available in case there is miscommunication in terms of your ability to follow. But this would not be the last session. We will have a few more as you start working on your CA1 module, CA1 assignment. You may have questions, then we will engage you along the way. So now I'm going to pass over to him and he will present the lecture. Tamil, I just gave a short introduction. You can take over. Yes.
Thank you, Professor. Thank you very much for your kind introduction, and welcome you all to Life Cycle Assessment. As Professor Siram introduced, I'm his former colleague, and good evening to you all. So to give you an introduction about myself, my name is Tamil, and I used to work as a research engineer. Let me close my video first. Yeah, it's distracting me here. All right. My name is Tamil, and I used to work as a research engineer at National University of Singapore from 2017 to 2021. My main focus during that time was conducting research on life cycle assessment and sustainability reporting. I had an opportunity to collaborate with Professor Shiram, and together we wrote a book called Sustainability for Beginners. If you are interested, you can find this link here. And as Professor said, I currently live in the UK and working as a Chief Technology Officer at Vision Zero Connect, a Nottingham-based consultancy firm. We are building industry-leading software like lifecycle assessment and sustainability reporting software, and we have gained significant attraction in the UK market, and we are expanding globally. If you would like to connect with me, you can find me on LinkedIn, and I would be glad to answer any of your questions you have about lectures or in careers of field of sustainability. So moving forward, in this lecture, first we will see the concept of sustainability and its relationship to life cycle assessment. Secondly, we will explore the fundamentals of life cycle assessment, including its methodology, scientific validation, and ISO standards in detail. And later on, I'll take you through an LCA demonstration software to give you an idea on how LCA works in real time. And lastly, we will have a very detailed introduction to CA assignment. So these are the table of contents for this lecture for today's evening. And moving forward, I would like to touch upon basics of sustainability. As you know, sustainability is a hot topic globally. And let us try to understand sustainability and life cycle assessment in detail in this lecture. So by the way, you can stop me anytime if you have any questions or doubts about the lecture. We do have a very comprehensive Q&A session at the end of this lecture. Please feel free to bombard me with any of the questions in line with these lectures that you have. So moving forward, first let us understand what is sustainability. According to United Nations explanation, the simple answer for sustainability is fulfilling the needs of a current generation without compromising the future generation need. Since we understood the basics of sustainability, now we may have to understand other aspects of sustainability as well. To what extent it is possible to fulfill our requirements without harming the environment or capacity of the future generations to meet their own needs. And we all know that without acquiring resources from environment, humanity cannot survive. And to find answers to these questions, we might carefully investigate recycling, an alternative product approach that are less damaging the environment. So how do you decide which approach or alternative methodology is most effective? So the ideal way of assisting us to make the informed decision is life cycle assessment. So one second. So the ideal way to assist us making informed decision is life cycle assessment. So if you see from this perspective, sustainability and life cycle assessment is interconnected. And without life cycle assessment, sustainability would be very difficult. So in summary, what I would like to highlight here, so to conduct a very comprehensive sustainability assessment, you need a comprehensive and scientific methodology to perform your assessment. So basically, life cycle assessment is a tool for you to perform a good sustainability reporting, right? So moving forward, we have seen that there is a strong relationship between sustainability and life cycle assessment. In general, as I said earlier, sustainability reporting helps businesses to measure their ESG performance. ESG is basically environmental, social, and governance performance, and set goals and adapt to change. For example, your business, you're running a business in Singapore and you want to reduce your carbon footprint by 20 percentage in 2030. So you have to have a scientific methodology to calculate your current performance, and you have to implement a right approach and strategy to meet that requirement, to meet your target and deadline. So in this way, the life cycle assessment is a helpful tool for you to create a sustainability report and evaluate how materials and products are reused. And it provides a specific indicators that shows how life cycle assessment would be very useful. So in summary, if you want to perform a sustainability reporting, LCA will act as a valuable tool, will help you to choose right material and right a product so that you can report your sustainability performance to your wider audience. So moving forward, let us see what aspects of sustainability will be benefited from life cycle assessment. As you can see here, the first one is environmental impact assessment. So life cycle assessment tool will help you to understand the environmental impact of a product. For example, if you want to measure environmental impact of a coffee cup, for instance, and life cycle assessment will help you to map out the entire process chain within the coffee cup manufacturing process, and it will help you to analyze the environmental impact associated with that particular manufacturing. And it provides indicators such as carbon footprint, water footprint, energy consumption, for example, and it will tell you the waste generation and many other indicators within your scope of work. So with this, you would be able to comprehensively measure the environmental impact of your coffee cup. And number two, which is emissions. So life cycle assessment is again help you to quantify emissions associated with your coffee cup, including scope 1, scope 2, and even scope 3 for instance. And it can help you to comprehensively measure a detailed emission profile of your coffee cup. And moving forward, resource consumption and efficiency. So in order to manufacture your coffee cup, you need resource. So LCA will help you to assess the use of resource such as raw material like paper, plastic, water, energy throughout your product life cycle. And indicators like material input, water usage, energy efficiency, can be evaluated. And with that, you would be able to precisely measure the resource associated with your coffee cup. And it will also help you to improve the efficiency of your process and product system. And then the final one is hotspot. What do I mean by hotspot? Is basically identification of your environmental hotspot associated with your product. And for example, let's say you are transporting coffee cup from point A to point B, and then you are using diesel operated lorry, for example, and that would significantly pollute the environment. So you can precisely map out which step contribute to the higher environmental impact. So with that, you would be precisely able to identify the hotspot associated with your product. So I hope you are clear with all these four key parameters associated with the life cycle assessment indicators. And these are the key indicators we always look upon when we build a new product or new services. So moving forward, I would like to give you a bit of introduction about life cycle assessment. As you can see from here, life cycle assessment according to ISO is to assess the potential environmental impact of a product or system or services at all stage in the life cycle. In a simpler word, again, I'm taking you to a coffee cup example. Imagine you have a coffee cup in your hand. The raw material used to manufacture the coffee cup is derived from paper that are sourced from cutting trees, plastic used for manufacturing lids, and transport used for shipping and disposing of your cups. These are the different life stages of your coffee cup. So now what happens? So we will map out each and every stages, and within the each stage of coffee cup, we can precisely and accurately measure the environmental impact of each stages. So moving forward, as I said earlier, the goal of conducting LCA is to pinpoint the critical areas in your product life cycle. And what we can do with this information, you can apply appropriate remedies and you can come up with strategic interventions to mitigate the environmental impact of any given stage. For example, transportation, you can replace diesel powered trucks with electric powered trucks, and you can reduce the environmental footprint of your product. So this is the overall objective of life cycle assessment. And we may have to understand types of life cycle assessment as well. So here we have got two types. Number one, which is cradle to gate. So what do I mean by that? So it's basically a boundary conditions. For example, you have a coffee cup and you take you take from raw material extraction to the finished product. And on the other hand, cradle to grave is basically if you want to conduct your assessment for the entire life cycle, starting from raw material extraction to transportation to manufacturing, warehousing, consumer usage, and dispose of. So basically, it's up to us to design set boundary conditions for our life cycle assessment. So we have got two types of life cycle assessment, and we have to use the right type of life cycle assessment for our selected objective. So moving forward, as seen in the left-hand side of the image, it's a schematics of life cycle assessment of various stages. And you can see here, it starts from resources and it goes on processing, manufacturing, distribution, use phase, and end of life. And these are the different life cycle assessment in your assessment. So, for example, I'll give you an example. If you want to transport your coffee cup, for example, from Singapore to UK through an aircraft or ship, so each transport has a different impact on environment. Hence, we can choose a better transporting methodology for our coffee cup, and this knowledge will help us to make informed decision and implement right strategies. Now let us understand the advantages of LCA. So why do we conduct a life cycle assessment in the first place? Saying from the business perspective, it will help us to comply with growing regulatory requirements. Here in the UK, we have a certain environmental policies. For example, if you manufacture a coffee cup, you have to have a limited amount of emissions, and you have to precisely map out your hotspot, which area you have got higher emissions. And with this scientific methodology, we would be able to minimize our environmental levies here in the UK. And secondly, it will give overall sustainability, improve our sustainability value, and it will build a positive brand image through environmentally friendly product manufacturing. And it will help us to design greener products, and it will help us to lead our competitors. So these are the key advantages of life cycle assessment. So in summary, it will help from multidimensional perspective, and it will help the businesses to improve your business efficiency, and at the same time it will help us to stay ahead of competitors all the time. Moving forward, so we have got a very nice graphics here, and let's dig into different life cycle stages in very detail. And as you can see from here, the stages include raw material extraction, manufacturing, transport, use, dispose, and recycling. So to conduct an LCA study, it is crucial to understand the inputs from nature. For example, to manufacture any product, coffee cup, for example, again. So you need inputs from nature, such as crude oil, coal, petrol, electricity. So these inputs are essential components of the system, and you need to comprehend the outputs to the nature once the product is manufactured. So during the manufacturing process, for example, you would likely to emit greenhouse gas emissions, and you would discharge polluted water. You would generate a solid waste. So you have to precisely map out what goes into your system, and you have to precisely map out what goes out of the system, and what are the output that you are emitting into the nature. So with this process mapping and combining all these different life cycle stages and putting all the inputs and outputs precisely into your system, you'd be precisely be able to set your boundary conditions, and you can potentially understand the impacts associated with each stages. Moving forward, before I move forward to this lecture, so you can stop me anytime and you can ask me questions. I'm happy to assist you. So here you have got typical LCA questions, and these relate to environmentally preferable choices or stages of your life cycle that contributes to your product design. So in principle, life cycle assessment aims to account for a trade-off. So what do I mean by that? It helps you to avoid a problem shifting. I'll give you a classical example. So you can see a disposal cup and a mug here. When it comes to environmental preference, mug is a clearly superior choice due to its longer lifespan compared to disposable cup. And similarly, if you can see on the third example, if we compare a recycle bag with a single-use bag, as a practitioner, I would always go for a recycle bag. However, let's see the second example here we have got, which involves manufacturing of electric car and using a fossil fuel as a primary source of petrol or diesel cars. So when it comes to emissions, fossil fuel cars are highly emitting, and it is important to consider that production of electric cars requires valuable resources such as lithium, and manufacturing of electric motors relies on scarce earth materials. So while we can reduce emissions from electric cars, on the other hand, we are also increasing the demand for valuable materials like lithium and other valuable resources. So as a practitioner, as an LCA practitioner, it is very crucial to maintain the balanced approach and avoid simply shifting the problem from one area to other area. The goal is to minimize the overall environmental impact and ensure the sustainable resource management. So these are the typical LCA questions we often get when we design a new system. So we always have to map out, we always have to compare our assessment with multiple different products so that it will help us to properly identify which product or system or methodology is suitable. And with that, we will be able to avoid a problem shifting from one side to the other side. So let us understand problem shifting in a simpler terms. So let's take a solar panel and wind turbines, which are known to produce clean energy without emitting harmful substances. So as an LCA consultant, your goal is to reduce greenhouse gas emissions. So you would design systems like wind turbine and solar panels, which are highly desirable. However, if you take a closer look of the manufacturing process of this energy sources, you will realize that these materials are these energy sources are heavily reliant on rare earth materials like quartz, neodymium for magnets, and this will also add more strain to the natural resources. So while you're solving the problem of carbon emissions by using the clean technology, you're also increasing the demand for rare earth materials. As a consultant, you need to find a balance between these two aspects. When modeling solar panels and wind turbines, you have to measure the carbon footprint from the different manufacture process and your entire life cycle. So in a nutshell, you have to precisely map out the resources associated with your methodology. And at the same time, you have to precisely balance your objective. For example, here, I want to reduce carbon emissions, but I don't want to increase the consumption of rare earth materials. So you have to properly balance everything. And with that, you have to implement right approach for your LCA study. So how do we avoid a problem shifting? Um, you have to quantitatively identify the problems as we discussed earlier and find a feasible solution that does not harm the environment. For example, we have to reduce our greenhouse gas emissions, but we should not increase the reliance on rare earth materials. So we have to precisely balance, and we have to understand from the global perspective also. For example, if you see, Asian countries are often hubs for manufacturing and recycling, which can lead to significant environmental and social degradation. As an LCA consultant, it is important for you to factor in these aspects and reduce the overall global impacts. And you have to come up with an alternative solutions to reduce your greenhouse gas greenhouse gas emissions, for example. If your solution leads to increased water pollution and it becomes less desirable, so therefore you have to find out a right balance and consider overall environmental impact aspect. So these are the key areas for you to come up with when you design a new life cycle assessment. The idea here is you have to quantitatively map out and you have to find out a right balance between your design and your desired outcome. So that's the overall idea of conducting a comprehensive life cycle assessment. So from this lecture onwards, we will see how to conduct life cycle assessment and methodology with examples and based upon the ISO guidelines. So before starting an LCA study, it is important to have a solid understanding of basics and follow a specific guidelines. So if you could see here, ISO 14040 provides a clear instruction for conducting an LCA study. So prior to these guidelines, we often use our own methodology, and that lacked transparency, reproducibility, and clarity. To address this issue, lifecycle ISO 14014 standards were developed, and according to this ISO guideline, LCA study involves compiling and evaluating inputs and outputs and potential impact of a product system, of its entire life cycle. For example, let's consider LCA study of a coffee cup we discussed earlier. In this case, you would need to consider the inputs from nature, such as resources, energy, and accurately calculate the environmental impacts like air pollution, water pollution, etc. In essence, following the ISO guidelines will help you to ensure the LCA study is conducted consistently and provide a reliable and comprehensive information about your environmental impact. So moreover, if you carry out LCA study using the ISO guidelines, it will help you to compare and evaluate your performance in relation to your competitors. It also serves as an official document that you can share to communicate with your stakeholders. And most importantly, before conducting the LCA study, it is crucial to understand you'll be working with a large amount of a complex data set, and these data sets should be properly organized, and this will help you to identify um, the available sources for you to conduct your LCA assessment. And we have a lot of software and databases available to assist you in conducting your LCA study. And the software like OpenLCA, SIMA Pro, and we are developing artificial intelligence-based lifecycle assessment tool here in the UK. So these are the tools and developing tools globally that will help you to precisely follow ISO guidelines and precisely map out your environmental footprint of your product. Moving forward, we have the ISO framework here, and it is important to understand and remember these four key steps, which we are going to discuss step by step in this lecture. The framework consists of life cycle assessment procedure and connections to practical applications. So the four main phases of LCA involves different types of data, assumptions, procedures, and calculations. And as you can see here, there's four steps like goal, lifecycle inventory, impact assessment, and interpretation. These are connected, interconnected, and these arrows emphasize that LCA is not a linear process, and it's a bidirectional process, and it's an iterative process where goal and scope can be refined based upon the inventory analysis that we have got. And the direct applications are not part of the lifecycle assessment. However, it will be useful for you to integrate your application of your product when you build your new methodology. So I want you to focus upon on this four stages as we progress through. We will see each stages and its features of each stages in detail. So from this point of lecture onwards, we will understand each phases of LCA in detail. Let's start with phase one, which involves defining goal and scope of your LCA study. We will use example to help you to understand better. And phase one consists of several subcategories as well, which we will cover in upcoming slides. The main objective of phase one is to define goal and scope of your project and to establish your system boundary. Let us begin by understanding goal of an LCA study. To help you to better understand, I have provided LCA framework on top right corner of the slide for your reference, which will help you to understand which stage we are currently dealing with. So right now we are dealing with stage 1, which is goal and scope. And secondly, you have to consider the application area of your life cycle assessment and how that will impact your product design. And it will also help you to understand your target audience, and it will help you to understand whether your results can be disclosed publicly, and whether you can compare with your competitors. So to give you an idea of coffee cup example, we want to measure environmental impact of one coffee cup, and my potential audience are my customers. And how are we going to disclose these results? I'm going to disclose these results through sustainability reporting. So with this, I have clearly established my system bound. So I have clearly established my coffee cup, sorry, my goal and objective, and it will help me to understand my potential outcome of my analysis. So once you have designed your uh, a scope, now you have to understand stages. So within the scope, we have got different stages. As I said earlier, stage 1 focus on the functional unit, which is your coffee cup, and stage 2 focus on your system boundary. In our example, we have taken cradle to gate, for example, raw material extraction to disposal. And stage 3 is your the data collection. How do you get different types of data to perform your assessment? So we have got databases, we have got different literatures, and we can interview your stakeholders to get all the data associated with your stage 3. So within the phase 1, we have got 3 different stages. Number 1 is your functional unit, and 2 is your system boundary, and a third one is your data collection. So once you have got a clear understanding of your scope, now we will move on to a detailed functional unit. So as I said earlier, the functional unit, it can be anything. So for example, I have considered here a coal-fired power station as our product system. And you can choose any product system such as water bottle, chair, desk, computer, and so on. This helps understand and determine which product system that we are analyzing with our LCA. And each product system has a specific function. In our example of power plant is to generate electricity, and we need to establish the functional unit of our product system. For instance, in this study, we have considered a coal-fired power station that generates 100 megawatt hour of electricity, and this is our functional unit. So you have to precisely map out a product system, function of your product system, and the functional unit of the product system. This is the stage 1. And you can take any of your product system, for example, a coffee cup. How many coffee cups? One coffee cup. And what is the function of your coffee cup? Is to store a liquid. It could be a container, it could be anything. So once you have got your clear understanding of your functional unit of the system, then you can move on to a different stages. So once we have a clear understanding of your product system, and the next step of our phase 1 is defining the system boundary. And if you look at the diagram here of our coal-fired power station, and we have a set of boundary conditions, and it shows the combination of different process involved in our study. Imagine you are conducting an LCA of this power plant, and the power plant relies upon coal as your primary energy source. And the coal can be obtained from surface mining, underground mining, and the coal should be transported to a processing plant and eventually end up in a power station where it burned and eventually converted as electricity. And this is the boundary condition. These are classical boundary conditions, and you can set a boundary conditions based upon your objective. And this will also help us to ascertain the overall project scope and limits the error in your design. So setting system boundary depends upon many factors. It defines where exactly to set your system boundary within the context of your LCA, and you can set your system boundary based upon the project scope. So you can set cradle to gate, you can set cradle to grave, and once you have clearly set your boundary conditions, and now you can start inputting your elementary flows that we are going to discuss. So once you have got your uh, stage 3, so we have discussed stage 1, stage 2, and now we have to focus upon the data collections. So once you set your boundary conditions, now we have to obtain information about the materials and resources that are used in our system. For example, in our power plant that generates 100 megawatt hour of electricity, which requires coal, limestone, water, and other resources to operate. To conduct LCA study, you need to quantify these materials in kilogram, liters, pounds, etc. So you can collect this information from public sources, databases, company documents, scientific data, interviewing experts, and you can precisely calculate all this informations, and you have to input this data into the system to conduct your life cycle assessment. So with this, we have clearly understood phase 1. So as I said, phase 1 has 3 different stages. Number 1 is your functional unit. Number 2 is your system boundary. And number 3 is your data collections. How are we going to collect the data? So once you have got a clear understanding, now we can move on to a stage 2, which is life cycle inventory analysis. In this part of lecture, we will understand what goes into the system, which are inputs like water, electricity, raw materials, and other natural resources. We will also explore what comes out of the system, which are output like emissions, water discharge, deforestation, and etc. We will go through a step-by-step process to obtain all this information and learn how to perform the calculations also. So if you look at the right corner of the slide, we are discussing phase 2 of our ISO framework, which is life cycle assessment, which is life cycle inventory. And according to ISO definition, the life cycle inventory involves compiling and quantifying the inputs and outputs. So as we mentioned in the previous slide, it is important to clearly define the input and output flows associated with your LCA study. To have a clear understanding of these flows, we refer as elementary flows, which we're going to discuss in detail. So the definition of elementary flows is given here. So elementary flows are the combination of input and output flows. Input flows consist of materials or energy that are taken from environment, while output flows are the materials or energy that are released back into the environment. The fundamental concept is that when conducting an LCA study of a product system, you extract energy or materials from environment, process them, convert them into a product, and release waste or byproduct into environment as output flows. So basically, what you have to understand here, you have to understand the input flows and output flows in detail. So I have given a clear representation of elementary flow in this picture. So if you associate the elementary flow analysis with our power plant example, the life cycle inventory contains input and output for each process at the point of each life cycle. In other words, all emissions discharged into atmosphere like CO2 or chlorofluorocarbons or impacts like resource depletion and resources derived from environment, etc. So the inventory list of elementary flow is shown in the figure. So inputs are typically obtained from external database, and it can be often user specific. Once the inventory is listed, now it is important for you to create a consistent output flows. For example, resource depletion or toxicity level. So the basic concept of LCA is to conduct the life cycle assessment of a product. You need to identify the manufacturing process involved in producing a specific product, and you have to identify the input flows and output flows. For example, you have got a different inputs for your any product. For example, let's say if you take a coffee cup, you have to have materials, water, and other input derived from environment. And at the same time, you have to precisely map out the output of your process, like wastewater. So how do you collect this information? You can collect this information from a different database. So these are the key things you have to follow upon while designing a detailed lifecycle inventory. So it's getting too technical now. So all we need is to understand the input and output flows of our product system. So once you have got a clear understanding of the lifecycle inventory analysis, now let's move on to the impact assessment. So first stage, we have seen goal and scope. And then the first phase, we have seen goal and scope. And second phase, we have seen lifecycle impact. Then once we have integrated these two information together, now we have to conduct an impact assessment of your product, selected product. So this is your third stage of your life cycle assessment. So in the top right corner of the slide, you can see the ISO framework, which indicates that we are dealing with phase 3, which is our impact assessment phase. To provide you with a basic understanding, this phase helps you to assess the environmental impact of your product. According to ISO definition, it involves evaluating the magnitude and significance of potential environmental impact throughout the life cycle of your product. So the impact assessment of any product can be tested using two methods. One is midpoint method, the other one is endpoint method. So the midpoint method is basically the elementary flows are connected to categories like human health or ecosystem quality. And endpoint method, it will connect to okay, damage categories like ozone depletion or climate change. So all I need you to understand here is for any given product, you have got two different methodology, and based upon the methodology, you can measure the potential impact of that particular selected assessment. If you want to measure environmental impact of a coffee cup using a midpoint method, you can understand damage categories like deforestation. And if you use endpoint method, you can understand how that would impact human health, for example. So these are the two different types of impact assessment method used in our LCA tool. So this is the I wanted to give you an idea of impact assessment through a graphical illustration. So once you have got your clear input and output flows, and later on you can come up with your impact assessment, and you can connect your material flows into different categories. Here we have got raw materials, emissions, and we have got uh, physical modification of natural area. So you can connect the your input and output material flows to your different impact categories. And with this, you can precisely map out your damage categories also. So with this, we have covered the different types of impact assessment. And once you have got a clear understanding of your impact assessment, and you can move on to your final stage, which is your interpretation stage. So as I said earlier, the impact assessment can be directly related to your goal and scope of your LCA study. When defining the scope, you have flexibility to choose which part of the product or process you want to focus in your life cycle assessment. You can choose to analyze environmental impact of a manufacturing process only, or you can choose your entire cradle to grave or cradle to gate based upon the boundary conditions you set in your phase one. So to give you a basic idea, if you focus only on a manufacturing process, for example, your assessment will be different from conducting an assessment for entire life cycle. So it's up to you to design the LCA study based upon the requirement. So you have to precisely define your goal and scope of your selected study, and based upon that, your impact assessment will significantly vary. And it is very important to choose the right impact assessment methodology also for your study. And once you have got a clear understanding of your impact assessment, and it will influence your outcome, it will influence your results in the interpretation stage. So uh, the idea of impact assessment is basically you have to quantify the outcome of your selected category. For example, in midpoint method, we have taken resource depletion as an example. Using this method, you can calculate various aspects such as amount of forest land in hectares that has been transformed, or the volume of water in gallons or liters that has been consumed, or the quantity of rare earth materials that have been utilized in your product. Now, on the other hand, endpoint method is also an interesting approach. It will help you to understand how product or process has impacted human lives. For example, imagine we're conducting an LCA study of a textile industry that discharge wastewater, contaminating nearby freshwater resources, leading to increased risk of cancer within the local populations. So with this method, you can even quantify and calculate the health associated with your local community. So these are the two impact methods that you can use to quantify and evaluate various environmental impact of your product. So since we have got a clear understanding of our impact method, now in the final phase, let us understand the interpretation. So after completing the goal, scope, and inventory analysis and impact assessment, and now it is important for you to derive the valuable insights from your study. So this phase focus on understanding the fundamentals of interpretation and how to create meaningful report based upon your findings. As always, as you can see in the right corner of the slide, we are now discussing the interpretation part of our ISO framework. And this phase is closely connected to other phases of framework, meaning that any changes made in previous phases will directly impact the interpretation phase that leads to a different outcome. So according to ISO definition, the interpretation phase involves evaluating the findings from inventory analysis and impact assessment in relation to your defined goal and scope of your LCA study. The purpose is to draw conclusions and make recommendations based upon the life cycle methods. In order to reach a meaningful conclusion of your study, it is crucial to carefully consider the results from other three phases of our ISO framework. And that will help us to take informed decisions and derive valuable insights. So if you want to get a more detailed understanding of the entire framework, you can refer to ISO 14040 and ISO 14043. That will give you a proper understanding with different examples as well. So I believe we have covered four key important aspects of our ISO framework, starting from goal scope. Second one is life cycle inventory. Third one is impact assessment. And then the fourth one is our interpretation stage. Once we have got a clear understanding of these three stages, now we have to identify the issues associated with our product system. And this stage will help you to effectively communicate your results and insights to your stakeholders. To create your final report, it is important to conduct three checks, which are completeness check, sensitivity check, and consistency check. These checks will help you to accurately map out your hotspots, and you can precisely implement strategies that we discussed before, which is basically a problem shifting. So by following these steps, you can come up with a comprehensive report, and you can effectively communicate with your stakeholders based upon your findings. This will help us to implement right mitigation strategy in our product. So if you see closely, the interpretation stage acts as the feedback mechanism to analyze the opportunities to reduce and mitigate the environmental impact throughout the whole life cycle of the product, process, or any services. With this analysis, you can implement changes in your product design, and you can change your raw materials, and you can change a different industry process. So this will help you to precisely map out the damages and hotspots in your each stages, and it can help you to communicate with your wide stakeholders of your product. So in this part of lecture, we have covered all four phases of life cycle assessment and gained a deeper understanding of each phase. And we started with the goal, scope, and we learned about a product system, functional unit, boundary conditions, and data collections method. And we discussed in the second phase, which is lifecycle inventory, we explored elementary flows and understood input and output flows in the product system. Then we discussed about impact assessment, where we learned different impact methods and categories used in environmental impacts of your product. And we covered interpretation stage, which helps us to draw conclusion and make recommendations based upon the findings. By understanding the ISO framework, and we have a very clear understanding of four different stages, and we would be able to comprehensively measure the impact associated with your product and your system. And it is also important to understand the limitations of a life cycle assessment tool. For example, if the product is manufactured in different locations, and it can be challenging to map out the entire life cycle. Data inconsistency are also very common in life cycle assessment. And again, setting boundary conditions such as cradle to grave and cradle to gate is also very difficult and requires careful consideration. And despite these challenges, LCA remains a valuable tool for calculating the environmental impact. And with precisely reducing the limitations, we would be able to perform a detailed analysis of our product, and we can come up with a sustainable and informed decision making in our product system. So with this, I hope I have covered life cycle assessment, foundational understanding and principles. And we have also touched upon the different aspects of life cycle assessment with a bit of limitations as well. And you may have to get a hands-on experience. Once you have a free time, you can download OpenLCA software, and you can get you can use my YouTube video tutorials, and you can play with a different product system, and you can measure the environmental impact of any selected products. So now let us understand the CA1 assignment guidelines. So we have already shared a comprehensive description of our exemplar reports and detailed description. And you can take any two products. For example, you can take disposable coffee cup or disposable coffee cup made up of paper and plastic, and you can collect the input and output flows of your selected product, and you can draw conclusion of the process steps and environmental impact. So to give you an idea, we have already provided a follow-through steps for this assignment, and you have to follow ISO 14040 and 44 principles to conduct your study. And the objective of the assignment is to enable you to understand the basics of LCA and help you to source information from internet and literature and compare two different products. So we advise you to enter your product selection in the attached link before September 10th. And if you have any questions related to your product selection, you can contact us and we can help you to guide you through. So yeah, with that, we have completed our foundational understanding of our life cycle assessment. And thank you for listening to this lecture. And I'm open to any of your questions.
Thank you, Tamal. Can you hear me?
Yes, Professor, I can hear you.
Okay, good. Okay, there's a small correction. Total number of words is 3,000, not 3,500.
Oh,
So,
sorry.
students, don't give them more work.
Okay.
3,000 words, yeah? Okay,
Okay,
we will.
Professor.
So the other one, Tamal, they said some students, ISO documents are not available. So what do we do with that?
I'll send you
Because,
all the documents.
yeah, because apparently we had to pay for it.
Yeah.
And
I'll send you
students,
those documents.
yeah, students obviously don't want to pay. Okay,
Yeah.
right. So okay, send us those ISO documents, so which
Yeah.
then I will put that in a Canvas system. I
Yeah.
will also tell them not to circulate or share because we
Yeah.
need to maintain confidentiality.
Yeah.
Okay, good. Okay, guys, any questions you have for him? I will pause the recording, otherwise it will be too much while you can still go ahead with the conversation. Yeah.